In 1983, the crew of the Space Shuttle Challenger came home with a small crater gouged into one of the cockpit windows. The culprit was eventually identified as a fleck of paint. Not a bolt, not shrapnel from a rocket. A fleck of paint moving fast enough to damage a window built to survive re-entry. Space, it turns out, is full of things moving that fast. And one physicist had already done the math on where that was heading. The reason a paint chip can do that is speed. Everything in low Earth orbit is moving at around 7.5 kilometers per second, roughly 10 times faster than a rifle bullet. At that velocity, mass almost stops mattering. A 1-centimeter bolt carries the energy of a small car dropped off a roof. And it never slows down because there's nothing up there to slow it. It just keeps orbiting, waiting. And there is a great deal of it waiting. Right now, more than 1 million pieces of debris large enough to end a mission are circling the planet. Dead satellites, spent rocket stages, shrapnel from old explosions, the occasional tool a distracted astronaut let go of on a spacewalk. 6 decades of leaving things in orbit, none of which has anywhere to be. All of it still up there. The physicist was Donald Kessler. In the 70s, his actual job at NASA was modeling how asteroids grind each other into gravel over millions of years. In 1978, he and a colleague asked an obvious and unsettling question. What if we had quietly built our own asteroid belt out of satellites? The paper they published is the reason any of us talk about this at all. Here is the mechanism, and it's the entire problem in one breath. Collisions in orbit make debris. Debris causes more collisions, which makes more debris. Past a certain density of stuff, that loop sustains itself, feeding on its own wreckage, even if humanity never launches another rocket again. Kessler's math said we were headed for that threshold. It took 31 years for orbit to prove him right. Now, you have probably seen the dramatic version. The 2013 film Gravity turned all of this into 90 minutes of wreckage, tearing a shuttle apart in real time. It is a great watch and terrible physics. The real cascade is not a wall of debris arriving at once. It is slow, statistical, and quiet. One collision here, another a few years later, each nudging the odds of the next. Which is arguably worse, because none of it ever feels like an emergency. The proof arrived in 2 parts. In 2007, China tested an anti-satellite missile on one of its own dead-weather satellites, Fengyun 1C. The test worked in the sense that it obliterated the target and created more than 3,000 new pieces of trackable debris in one of the most crowded lanes in orbit. Almost 20 years later, most of that is still up there, still crossing everyone else's path. The second part was the one Kessler had actually predicted. In February 2009, a working American communications satellite and a dead Russian one arrived at the same point above Siberia at the same instant. Nobody fired anything. Nobody made a mistake. 2 catalogued objects simply met at a combined speed of well over 30,000 kilometers an hour and produced 2,000 more fragments. The accidental cascade was no longer theoretical. So why not simply watch the sky and steer around it? We do watch. Ground radar tracks over 40,000 objects, which sounds reassuring right up until you hear the limit. About 10 centimeters. Anything smaller is invisible to us, and there are more than 1 million of those, each still large enough to kill a satellite. You cannot dodge what you cannot see, and the things we can't see outnumber the things we can, by something like 25 to 1. Cleaning it up seems like the obvious answer, and it is, until you look at the physics. Every piece of junk tumbles unpredictably in its own slightly different orbit. Reaching a single one costs essentially a rocket launch. There are millions of them. The arithmetic of retrieval simply does not close, which is why, after decades of very clever proposals, the total amount of debris actually removed from orbit so far rounds to roughly nothing. And we are not slowing down. If anything, we're accelerating. Starlink alone now operates several thousand satellites, with tens of thousands more planned across a dozen competing constellations. More satellites means more things to hit, more things to become debris, more chances for the statistics to find an unlucky pair. Which brings us to the part that should genuinely worry you. Because the thing a runaway cascade threatens is not space travel. It is the flaw of modern life. GPS is satellites. Weather forecasting is satellites. So is a startling amount of banking, aircraft navigation, disaster response, and the time-spun the card you just tapped. A bad enough cascade would not strand a handful of astronauts. It would quietly switch off infrastructure most of us forgot was even in the sky. The one mercy is time. Orbits decay. Left alone, low ones clear themselves in years, high ones in centuries, which is either comforting or alarming depending on how patient you are. And the cascade is not inevitable. Deorbit rules are tightening, collision warning systems are getting sharper, and the first clumsy cleanup missions are genuinely flying. This is a solvable problem. It is simply not yet a solved one, which is the part I find genuinely new. We have polluted rivers and air and the climate, and we noticed every single time only after the damage was done. Orbit is the first environment we can watch filling up while there is still room to stop. That fleck of paint in the Challenger window was not an accident. It was a very early, very small invoice. The only real question is whether we read it before the rest of the bill comes due.